we are doing second derivatives. Luckily, there's no new process here. It's just a repeat of the same process we already know and just the new symbols that represent it. So if we kind of look at here, we have what looks like exponents, but that refers to the second derivative. So it's all in context. In this context or in this form, this is your second derivative. And remember, this can also be rewritten with the y to the side. So we can kind of see this is the second derivative of the y function. All right, and then there's the function that we have right now, y equals 4 sine of 3x. So let's go ahead and just jump right in. We do the first derivative, step back, and then we do the second derivative. So first, let's go ahead and find d dx of y. So this is the first derivative, and then we'll go ahead and find the second derivative. All right. So the first derivative here, I'm not going to worry about that. 4. The derivative of sine is cosine. We repeat what's inside the trig function, which is 3x. Since this 3x has more than just x inside, we have to be careful about the chain rule. And the chain rule applies here, so the derivative of the inside function is just 3. So this will just simplify it. So this is now equal to 3 times 4 is 12 cosine of 3x. And that's dy dx. Now we'll go ahead and just apply the derivative one more time. So this is d2 dy dx2, which is equal to, we do the derivative one more time. I don't worry about the 12. The derivative of cosine is negative sine. We repeat what's inside the trig function, which is a 3x. And then we have a chain rule applied here again. The derivative of the x function inside here, the composite, is just 3. So times 3. Simplify our work. 3 times 12 is 36. We have that negative we'll put out in front, and it's sine of 3x. Negative 36 sine of 3x. Negative 36 sine of 3x. There it is right there. So all we're doing is we do the derivative once and then do the derivative again. Just being careful of matching the symbols that go with it. We have a little bit of a different notation here, so we'll go ahead and attempt that. I'm going to get out my cheat sheet right now for my exponential functions. So anything that doesn't pop into my head, I'll probably have on my cheat sheet. That's why I put something on my cheat sheet. If I don't have it memorized, then it goes on my cheat sheet. So this is an exponential function. X is in the exponent. So I have to look at my cheat sheet because I don't have it memorized. And there it is right here. So let's just go ahead and rewrite it. The derivative of some number a to the x is going to be the natural log of a times a to the x. All right. So notice we have a second derivative going on here, so let's just go ahead and take care of the first one, then apply it one more time. It looks like we're going to have a product rule going on here, which is very common with the second derivatives. Anytime they're not straightforward, just like a sum rule. So let's go ahead and h prime of x is equal to, so this is 2x, so the a, in this case, the number that's the base is the 2. That goes in the natural log, so it'd be natural log of 2 times, and then we repeat the exponential function, 2 to the x. Okay, that's all there is to it. Now, for the second derivative, we have a function times a function. So that's going to be product rule. Remind yourselves of what the product rule is. A lot of my students are kind of still struggling with it. So d dx of f times g is going to be equal to the derivative of the first, is what I say, times the second, plus derivative of the second times the first. So let's go ahead and apply it and go from there. All right. Now, in my notes, I don't see that I have the natural log derivative. I always like to kind of look ahead. I do have the log derivative. So I'll go ahead and I'll just rewrite this in terms of log, and then I'll apply the product rule to it. So this is still equal to, this is h prime. I just want to put it in a form that I can deal with a little easier. So this, how do we rewrite natural log as a log? It's log base e. 2, all of that function times 2 to the x. All right, so this is what I have in my notes, the log derivative. Okay, so I think we're ready. H double prime. So this is also a representative of a second derivative of x. All right, so we just apply the derivative one more time. The derivative of the first. So let me go ahead and put this in my my side work right here, or my notes to reference. So the derivative of log, in my notes, log base a, and this is d dx, of log base a of x is equal to 1 over natural log of whatever that base is times x. And that's going to be separate by itself, separated. All right, let me just double check. 1 over natural log a times x. Okay, I think we have everything we need now. So double derivative. The derivative of the first is going to be this. 1 over natural log ln of the base e, that's nice already, times x. What's our x in this case? X is 2. It's going to be times 2. Derivative of the first times the second. So all that times 2 to the x. Plus derivative of the second, which I have right here, natural log of the base, which is 2, times, repeat the exponential function, 2 to the x. So that's the derivative of the first times the second, which is, in this case, I think I'll just use natural log 2, which is this right here. So it's a repeat of this function, natural log of 2. All right. So let's go ahead and put things together that we can and simplify. Well, this 2 to the x would go on top, so I'll just write it up there. I'll move this 2 in front. Notice we have a common base here. I'll just go ahead and put a little 1. I'm not real in tune with my laws of exponents, but I can see that they have a same base, so these probably combine. I'll be careful about that. And natural log of e. So this is log base e of e, which undo themselves. So that's a 1. Okay. So if we needed to, let me just be ultra careful. Log base e of e equals what? I'll call it, we don't have a y floating around. I'll just call it y. So if I were to rewrite this, logarithms are always equal to the exponent. So the base is e, and then the answer is going to be e. And so yes, if everything's the same as the base, then the exponents are the same. So that's a 1. So all that means that when you have a log with the same base as the number, it undoes itself and it's equal to 1. Got it. All right. And then got all that. Plus, we got natural log of 2 times natural log of 2. So that's ln of 2 squared times 2 to the x. Things that jump out at me. I'm not so sure. It's getting a little messy and getting a little tricky. So I'm just going to go ahead and keep simplifying, see if anything happens. So when we have the same base, here, that means we are subtracting the exponents, and the subtraction is going to be the 1 on the bottom. So all of this is equal to 2 to the x minus 1 plus ln of 2 squared and times 2 to the x. Let's see, I could pull out the 2 to the x also. So let's see. I'm not going to go down this way. I'm just going to try a different one. So I have a 2 to the x here. I have a 2 to the x here. I'm going to factor it out, see if that helps. I didn't really like the way this looks. 2 to the x gets factored out. What's left? I still have a 1/2 plus ln of 2 quantity squared. All right. ln of 2 quantity squared. Let's see if that does anything. I don't think it does. Let's check. Desmos ln of 2 squared. Let's first see what ln of 2 is. Ln natural log of 2. All of that gets squared. Well, that doesn't look very good either. Well, we should have an answer that's clear, and both of the answers that I'm getting are not very clear right here. So let's go ahead and see what I missed. All right, so I'm just going to go ahead and use the hint. So my final answer was this 2 to the x monster right here. Let's see what the hint says. All right, so we're doing it twice. Yes, we're doing it twice. Another hint. All right. The derivative of 2 to the x is ln derivative of 2 to the x is ln of 2. Let me go ahead and clear this so we can just see what's going on. All right. So in my notes, the derivative, yes. So this is good. Derivative, yes. So that's good. We had that already. So there's the first derivative. Second derivative. So the mistake was that ln of 2 is just a constant. So we would just focus on the derivative of 2 to the x. So my mistake was that I treated it as a function. There's no x here. So I'm going to go ahead and check my work and see what mistakes I made. But yeah, then we would just repeat the derivative, and that's all there is. And yeah, so it's the squared of natural log of 2 times 2 to the x. All right. I'm going to go ahead and stop it here and see what mistakes we made.